I'm Merlin from the product at OLake, and I'm really glad to welcome you all for today's webinar. This webinar is really special for us as we are here for the official launch of our product OLake V0, and I'm really excited to have you all on board. So without any further ado, I'll hand over the stage to Shubham, the co-founder and CTO at DataZip, who will be taking you through OLake and its capabilities. Meanwhile, if you have any questions, please drop them in the question box, and we'll be taking them up right towards the end of the session. Over to you, Shubham.
Hey, thank you, Marlene, for the good introduction. I hope I'm audible to everybody here, right? Yeah, cool. So I'll quickly start with a simple presentation. Let me remove this. So today we have a really excitement announcement for you. Like we are launching the OLake V0. So I'm pretty sure like people who have attended the previous webinars, they already know me. But for the new people, I'm one of the co-founders and CTO here at DataZip. We are creating a product called OLake, which is a fast and lightweight Golang-based framework to ingest your data from databases to Iceberg. So Iceberg is basically the Apache Iceberg that I'm talking about is a lakehouse format, which is one of the most popular format of data lakes. It's a relational data lakehouse platform if you're not aware of it. As a part of today's session, we are going to see what are the challenges with the existing ELT tools, especially when you ingest into Apache Iceberg. What could be the challenges and potential improvements that you can do when you're ingesting. Apart from that, a lot of exciting features that we are launching with this launch. We will also show you a couple of benchmarks and a couple of new exciting features that we have in our roadmap down the line. And finally, we'll give shout outs to the contributors who have contributed to us in last 2 months almost. So I'll quickly start with the challenges that we have seen people facing while ingesting their data using the existing ELT solutions or paid ingestion tools, right? So one of the things that has happened in last decade, people have moved away from data warehouses to data lakes or data lake houses because amount and the scale of the data increased, and also the use cases of the data increased. So warehouses were really good in catering to gigabytes to terabytes of data. But as the data grew, now lake houses like Iceberg are supposed to cater to terabytes and petabytes kind of a scale, right? And with the limited kind of focus that the existing tools have around the Iceberg and the ecosystem, it just gets really like difficult for the people to get their data into the Iceberg without having to spend a huge amount of money or without having to have a huge engineering burden, right? For example, a lot of the pipelines that we have seen which are ingesting into Iceberg are based on Kafka, Flink, Spark, Debezium, and which has like too many moving pieces, too much of engineering bandwidth goes into that. And also we see that not a lot of these tools are like generic. They are like M sources to end destinations. So they have to focus on a lot of like moving pieces as a part of the offering itself. So, but here we are fully focused on high scale ingestion, which where we are focusing on data sources which generate a really high amount of data, and which and only one or two destinations which can cater to such a high amount of data as a dump, right? So we are primarily focusing on databases like Postgres, MySQL, MongoDB, Oracle, and we are also going to introduce sources like Kafka and S3 soon. And the destination is basically the Parquet, simple Parquet-based destination or Apache Iceberg. So that's what we are focusing on. We are trying to remove the rigidity around like these existing tools have, and trying to focus really on Iceberg so that we can offer really detailed and really like a reliable support for partitioning, ordering, schema evolution, and data type misses or data type conflicts. So, like particularly when we talk about Iceberg, the ingestion to Iceberg is challenging because companies who are using Iceberg are again like they have data from terabytes to petabytes. So when you're doing that kind of ingestion from the OLTP systems like databases or Kafka, where a lot of your events data is coming in, it kind of like it's a really tricky because you need to handle for the scenarios like spikes in the CDC logs or wall logs, bin logs. You also have to handle sudden spikes in Kafka events, right? Some of the existing tools that are there, like paid offering, like Fivetran and Nearby, they do support all of these sources, but the amount of data that they cater to per customer is kind of like averagely they cater to less than a terabyte, which is primarily because they are really good in like SaaS sources. But when it comes to like enterprise scale, when you have data per month, like 100 terabytes or more, like hundreds of terabytes of data, 5 ton nearby, they can cater to it, but one, they are slow, and another, second, they kind of get really expensive as the data volume grows. They grow like super expensive. So that's where we saw an opportunity that we have to create something which is kind of catered to that high scale kind of thing, and also like don't have a huge burden on the people's pocket, right? Uh, and why we are just using Iceberg? Like this is one of the main questions that we get when we reach out to the people. So we firmly believe that Iceberg is going to be that storage format where at least for next half a decade or decade, everybody is going to be on Iceberg eventually. And we see the industry is moving towards it because all the major query engines like Databricks, Snowflake, they have added a good support for Iceberg queries. They are even adding support for Iceberg writes. A lot of new catalogs has come up. All the ecosystem is actually now more or less compatible with Iceberg, at least reads, I can say. So there is no vendor lock-in that you have to kind of get binded to, and then once you get locked into a certain kind of a vendor lock-in, you have to pay millions and millions each year, right? Apart from that, like couple of pipelines that I have seen in the past, like where people have a data duplication when it comes to solving for multiple use cases. Like you have dumped your data into data warehouses for analytics, but now you have to export it to S3 in terms of Parquet, because you have to do ML on top of it, machine learning on top of it, right? So now you have to maintain the sync as well from warehouses to, let's say, the S3 Parquet. And this is again a data duplication. You have to pay more for the data storage. So in Iceberg, you don't have to do that, right? It basically one source of truth for everything. So the couple of other features that Iceberg offer is a schema evolution, time travel, asset compliance, which is like a regular data warehousing table features. Iceberg has a really good support for partition pruning, where we have realized that once you have a terabytes or petabytes of data, you need to skip scanning the data to kind of make your queries run faster. One of the main things and the reason why we have chosen Iceberg is the PMC of Iceberg has a lot of bigger companies like Apple, LinkedIn, Netflix. So we know for the fact that Iceberg is going to stay there for the next decade for sure. So as a part of this launch, we are going to list down the features. So, but apart from all of this feature listed here, like the first thing that we are launching is the UI as a part of this launch. Like we have created a really cool UI, which I'm going to show you as a part of the demo. But quickly listing down the features, like we have the core framework itself, and the UI is Apache license, so you can run it without having to worry about any licensing things. We do understand that when you are kind of ingesting the data from your databases, for the databases of enterprise or early enterprise kind of a scale, you need a faster historical load. So what we do is we chunk the bigger tables into smaller pieces, and we process these pieces parallelly, so that we stream that data in a really fast way into the Iceberg. uh, you can actually achieve like 1 minute kind of a near real time latency when it comes to the ingestion with OLake. We do support all the primary catalogs that Iceberg as an ecosystem has. And also, like one of the features that when I interacted with a lot of customers, I got to know that, and particularly from the customers who come from a Debezium kind of a background, that they have a hard time to add a new table into an already running sink. So we have made it super simple for you to add new tables in the existing sink. You just have to go to UI, select the table, and that's all. Like OLake will take care of all the multi-threading and all sorts of things uh, when you want to pull the snapshot of the table, and also after the first full load or the snapshot is done, you can continue with the CDC again. Apart from that, a couple of other features like resumable full load is there. So if sync breaks in between like half the way that you are there. When you restart the sync, it will like keep just processing like the remaining half of the table, so you don't have to process like all the data again. We are making this resumable using the chunking. We'll only process the chunks which are left, right? Apart from that, like schema evolution is there, basic like deleting a column, renaming a column, adding a new column. All of that is handled. We are also, as I mentioned, as a part of this V0 launch, we are going to offer a simple DLQ feature where we are going to dump the data into a new DLQ column. So you don't have to worry about, like if your data type conflict happens, if your data types are changed, and this usually happens in the cases of, let's say, MongoDB kind of a databases. So you don't have to, like, the sync will not break. It will just keep on dumping onto a new DLQ column as a part of as a JSON basically. So moving ahead, like we have a really basic high level architecture diagram here. So as a part of the offering, OLake UI is going to be there. We are also giving you a temporal for the orchestration. So in the OLake UI, you will go and you will enter the credentials of your source database, and you'll also enter the credentials of your destination, which is going to be the S3 bucket and your catalog credentials. And once you have set up the job or the sync, it will kind of temporal will take care of orchestrating it. So it will spin up a OLake container, which is going to take the data from the source, pull the data from the source, and dump it into the Iceberg table, which you are eventually going to use for the analytics. You can ask all the questions. You can keep asking the questions on the chat, but I'll answer it once I end the presentation. So inside of the OLake architecture, like I want to particularly point out that we have worked on a chunking basis on the type of the database that you're syncing. So if you have MongoDB as a database, we have splitting or chunking strategies like split vector, bucket auto. For Postgres, we do have CTID kind of a chunking strategies. Particularly for this, you can read a good blog that we have around how each of these strategies work. How do we actually split the tables? Each of these strategies work really well in the form of, let's say, if you have your data in ordered by a certain column, you can use timestamp based. If you don't have an order, you can use split vector and all of that. So you can read that blog, and you will understand how each of these work. As a part of the architecture, when we started, we decided that we don't want any of the extra infrastructure to run. So you don't need any Spark or Flink or even an orchestration framework to make it run. Like, you can simply run it as a part of a Docker Compose. In the future, we do have some plans to launch a scalable Helm offering as well. Apart from that, we do have a CLI and GUI both. So if you already have an existing Airflow kind of a pipeline, you can, from that Airflow kind of a pipeline, existing pipeline, you can call the Docker CLI so that you can basically integrate OLake into the Airflow pipeline, or you can also call the GUI APIs. So you can just simply trigger the sync via calling an API so that you can reuse your existing pipelines and just make OLake as a part of it. On the destination side, particularly on S3 and Writer, S3 Writers and Iceberg, we have leveraged one fact here, which is object source like S3, Azure Blob Storage and all. They have really good write performance. You don't have any limits on how fast you can write compared to some of the existing warehouses like Snowflake and Redshift. Like you need to wait. Like, you can achieve a really fast write, but again, that comes up with its own cost. But with S3, it's not like that. You can actually load data in parallel and dump data into parallel into S3. You just have to take care of when you're committing in case of Iceberg. So we have leveraged that, and that's the reason why we have made the syncs so fast. We are also taking care of one really important fact when it comes to Iceberg, that you basically, when you do the full load, we are going to create the parquet size that we dump into Iceberg a little optimized around 500 megabytes or 256 megabytes, so that when you query the tables, Iceberg tables, the query performance is really good, and you don't have to do one more compaction just because the ingestion files were not at the right size. So we save you from that overhead as well. And particularly around the delivery, and this is one of the features that we have worked towards a lot, that we offer exactly once delivery, and this is really hard to achieve when it comes to achieving this in cases of, let's say, if you have a manually written pipeline using Debezium or Kafka, right? You have to work one extra mile to achieve this. But with OLake, you don't have to worry about that. All of your data is going to be committed only once the reading for a particular chunk is finished or reading for a CDC is finished. So when you query the data, you don't have to worry about if there are going to be duplicates in your Iceberg table. And this is, a lot of people have uh, told us as a part of the discoveries that they face a hard time to achieve like exactly once. Here we have a basic kind of a architecture of how the OLake writer works. You can, again, like Harsha and Merlin can share the link. We have a really good doc around it. You can read how the OLake architecture works. So moving to the next slide, we have some core framework as a OLake as a framework capabilities, which are really important when it comes to making it production ready. So one of the main important uh, function is concurrency control. So we understand that even if we can load the data really fast, but we cannot overwhelm your databases by like throwing tons of queries, right? So we have created this whole framework so that using just one parameter, you can control how many connections that you want us to make to your databases, and all the chunking and the CDC that is going to happen are going to use this parameter to control the number of queries and number of connections. Apart from that, as I mentioned, there is a resumable full load or historical load. We are going to publish a lot of monitoring and metrics features soon, so that you can actually see how many rows you have synced, how many times your syncs have failed, how fresh is your data, and all of that, right? Apart from that, we do have a lot of interfaces and abstractions. So in case you want to write your own connectors going forward, you can simply extend to those interfaces and write the main logic or the core logic for that. And all the things around concurrency or exactly once semantic is all is taken care by the OLake framework. So you just have to worry about writing the main logic if you want to extend this to write maybe a new database connector or a S3 connector, any new connector, right? Particularly with this, we also want to point out that each of the connectors, they have their own data type conversion kind of a feature, so that you have a really tight control on if you want to control a float column from Postgres to a float 64 in Iceberg, right? That you can decide. And we have really specifically pointed out correct data types for existing all the sources. And this is we are able to do it because we are just focusing on less sources and less destination. We want to create the best product out there. Moving ahead, so we have a benchmark. We have run the benchmark on Postgres for OLake versus all the existing tools available in the market. So with 50 million rows, and this is particularly for CDC. It's not for the full load. Full load, we have the benchmarks already published on our website. But for CDC, we were able to achieve 40,000 RPS, and we were able to load all the 50 million rows for the CDC in just 20 minutes, 22 minutes. And particularly like all the other tools, as you can see, they have taken some good amount of time when it comes to like loading 50 million records. But again, we are adding a lot more features on top of this, so you will see the speed improving maybe 3x or 4x going forward as well. Moving ahead, I'm going to show you a quick demo of the UI that we have just launched. So this is how the UI looks. Let me just refresh once. Yeah. We have some level of jobs. Jobs is basically kind of a orchestrated sync from source and destination, and source and destinations as well. So I'm just quickly going to start by creating a job. I'm hoping that you guys can see the screen, right? So let me quickly figure out for the credentials. So I'm adding the Postgres as a source. Let me see the name of the database. This initial wait time is basically it will wait for the CDC messages to scan the CDC messages. If you have tons of CDC present. So this is Postgres replication slot, which I have created. And we are going to add a batch size as 10,000. So this is the parameter that I was talking about around concurrency control. So for now, I am just gonna use like two, because I'm just gonna sync a small table as a part of the demo. In the right section, you can actually see the docs of a particular connector. So when I basically press the next, it will actually check if it's able to read the data from databases. Just give me 1 second. Maybe I have missed out on something. So it's basically this will actually test if it's gonna read in your database. And as I think I have still made it wrong. It's 5432. Sorry. I'm able to show you like a demo of the failures as well. So that's cool. Just this will take like a 5 more seconds. Awesome. So yeah, I'm going to sync to Iceberg, and we do support all the popular catalogs, Glue, REST, JDBC, and Hive. Particularly like as you can see, like all the parameters are mentioned on the doc on the right side. So let me name this as, I'm going to quickly copy the S3 path. So I'm not putting up the secret key and access key because this instance that I'm running this on is already configured with the credentials, the IAM roles. And I'm going to use database as OLake demo. So basically, Iceberg is going to the Iceberg destination is going to write the data in this bucket on this particular path, and is going to create a database in the Glue catalog if it's not already there. So you don't have to worry about taking care of creation of database or any manual schema and all. So now once we have set up the source and destination, we are going to get the list of tables which is there in our Postgres. And with the list of tables, you can just select a couple of tables that you want to sync. And you can also select like all the parameters, like if you want to sync, like just a full load or a incremental load using CDC. So let's say I'm just going to select one table which I've created just for the sake of this demo. So in this, uh, as I mentioned, like I can basically select options like normalization. So while the time of ingestion, I can basically flatten the data. I can also see the schema or the columns that are there in my Postgres table. And I can also define like partitioning as a part of the setting of this table. So as most of the things are set, I'm just gonna click on next. And let's say I just name this as a job. I'm going to mark the frequency as 1 year. You can set the frequency here so that you can, keep on running the job incrementally on a couple of minutes or hours or a day basis, right? So for now, if I just create the job, so my job is created. Now I can trigger it manually using sync now. So this will just take like a couple of minutes to be synced. While that is happening, I have my Athena open, so I can query the Glue catalog from here. Right. As of now, as you can see, like there is one table that is created just now. So this is a so my sync is running now. So this table that you see here, which is created, it's part of a test connection kind of a thing where we check before we pass the destination creation that you are able to write to the destination or not, right? And now the sync is running. So as a part of the sync, I can see that 10 records are synced for the table demo. So if I go ahead and refresh this database OLake demo, I can see one more table. And if I query from this table, I think we should be able to see all the data that is there in the database. So I'm just quickly going to update one record that all the data is synced, but I'm going to update one of the records. let's say I'm going to update this OLake ID 9898. I'm going to make change in the short URL ID with some value. Just give me 1 second. I'm sure that you are not able to see my screen because I've just shared the Chrome. So I've changed the value of the short URL ID here as OLake demo. And if I go ahead and I just trigger the sync again. So yeah, the sync is running. So you can actually see the logs. Sometimes it just takes like a second. So now I have updated one of the records with the ID 9898. So when I sync, it should only sync like one record at the end. Yep, I think it has synced that record. And when I just go ahead and query the table, and just to show you like the current value for this is empty. And if I run it again, so yeah, as you can see, this record 9898 is up, like updated. All of the other records are red, but this one is updated. And you also see the CDC time, like I have just updated it right now, and I have updated the value to demo time. So this is how easy we make to sync your data from your databases to Iceberg, and that's a quick demo. So I'm just going to move to the next slides. So as a part of the future roadmap, we have Oracle as a connector, which is just going to be launched in 1 week, at least the full load of Oracle connector. But we definitely are going to launch the incremental sync for the Oracle in next sprint. For Kafka as a connector, we have already raised the PR, and that PR will be merged soon. For the V0 of Kafka, we are not supporting normalizations. We just have a full load and full and incremental load. But this is mostly going to be like we are going to dump the denormalized data. Observability and monitoring features are going to be added, including alerting, metrics, and freshness kind of a thing. We have a lot of exciting feature as a part of the framework coming up. So we have a heart beating mechanism, something you might have seen in Debezium. So where this is going to help is it's going to help you skip the a lot of CDC data if the tables that you're syncing are updated rarely. So this will allow you to not have the bin log or a wall logs bloat. Like a lot of times, if you don't sync or if you sync it really like less, or your tables are updated really less, the wall log for Postgres has a bloat up, and then your database or it's a risk for your database. Apart from that, we are also going to launch an advanced watermarking kind of a feature where when you add a new table, so you don't have to worry about if your old, like while you are syncing the old data, your wall log is going to have a bloat. So this is again one of the difficulties that we have seen a lot of companies with a high scale. If they have a wall log bloat, their database stops working a lot of times. And a couple of other features like incremental sync modes, again for all the databases, like a cursor-based sync mode, you can see maybe 2 or 3 sprints down the line. So this is a cursor-based mode where you can just simply specify updated at or some level of like a bookmark column, and it will keep on syncing new data based on that. Apart from that, filtering, this feature has been requested by a lot of users for the full load and the CDC both. One of the requested feature is like, can we deploy this on our Kubernetes or on-prem deployments? So we are thinking and planning to launch help, but as of now, the features and the product requirements are not fixed for this. Partition evaluation is something that, as a niche Iceberg feature, we are going to launch. Apart from that, couple of innovations or couple of innovative features around the Iceberg that we are planning to launch is lightweight compactions. So as a part of the offering, like while we are ingesting the data, we understand we will be creating a lot of smaller files for CDC kind of a use cases. So we are also going to see if we can kind of merge these small files and dump it into a little bigger file, so you don't have to trigger your compaction really frequently. So we're making sure that your data is actually more optimized for the query by doing a lightweight compaction or with some of the other strategies like clustering and ordering while you ingest only, right? So this is a part of our future roadmap. One of the things which is not mentioned here is we are actually contributing to Iceberg Go as a project as well. And we have written everything in Golang. So Iceberg Go as a project, we are planning to integrate in the OLake as a stack. Right now we have a Java writer, but eventually we will integrate Iceberg Go. And we have already done some benchmarks. In terms of the benchmarking, it's actually 5 to 7 times faster than Java. And this is just a really surface level benchmark. When we actually implement it in a really fast way, it can actually be 10x faster than Java as well. So that we are already working towards. As a next step, like I would like to give you a shout out to a lot of people who have contributed a lot of great features. I'm not going to name every feature, but like a couple of good features that we see is main releaser is contributed by Barun, and S3 table support is contributed by Lalit. Apart from that, couple of bug fixes around documentations or formatting, logging, uh, also like some level of I would say like documentation updates are also there. So shout out to all the contributors and thanks for contributing. Uh, we really appreciate and look forward to your contributions. Sorry, I just skipped to the next slide. So this slide is just a simple slide. I want to show OLake project growth. Like in terms of the open source projects, we have started exactly 5 months before, and we were able to achieve like 900 stars. And the community also, we have 200 people right now on the Slack. And the amount of growth that we have seen in last 5 months is really good. A lot of people are excited about Iceberg, and they are doing a lot of POCs using OLake as well. And we see a really good amount of questions on the Slack. Like recently, for last couple of months, we have seen people joining and asking a lot of questions. So we see it as a healthy community growth, and we would like to thank everybody who has liked the repo. And please, like if you have who have basically started the repo, please start the repo if you have not yet, right? As a matter of this presentation, I'm done, but I'm going to take question and answer soon. So before I move to the question and answers, like you can simply scan this QR code if you want to get the GitHub or documentations or Slack. Just a second, I'll stop sharing my screen, and I'm just going to share one of the tabs so that it's actually open for you. Right. So I'm seeing a lot of questions.
Thank you, Shubham, for the presentation. Yeah, we'll be taking the questions one by one. So Naman had asked this question. How does Iceberg handle heavy data merge shuffles?
So just to understand, like using the heavy data merge shuffles, there are two kinds of what I'm trying to understand or get from this question is one of the shuffles that could be there, or data merge could be there, is kind of a compaction. So when you ingest the data, you might create a lot of smaller files. So for example, if basically you ingest 1,000 updates and the table is like a billion rows table. So for that, what Iceberg creates is Iceberg creates a delete file, and we use the equality delete as a feature to write that data into the Iceberg. And using that equality deletes, the query engines which is reading the table, they will process this updates that we have added on the fly. So they will read all the data and they will process these updates which are present in the delete files on the fly. Second thing is, if you're asking about the query, so query basically if you're querying it using Spark, Spark handles Iceberg queries in a really simple, like in a normal Spark way. And Spark has a lot of dependencies on Iceberg libraries. So basically, which guides Spark to more on the basis of how to merge the data, depending on a lot of metadata which is created around the Iceberg Parquet files. So that also helps Iceberg to scan, basically Spark to scan lesser data and merge it more, like optimized. I hope I'm able to answer the question, because the question is a little, you know, confusing. Yeah.
Yeah. Um, the next question that we have is from Roy, and he is asking what data lineage features are there on the jobs, like monitoring, BI, etc.
As of now, there are not. Like we, as a part of the V0, we don't have any lineage features. But as a part of the roadmap, we are going to have Iceberg V3 implemented soon. And Iceberg V3 has like a lineage features which you can basically track and see how your data is flowing, particularly if you have a medallion architecture or anything, right? So, but it's going to come soon.
Um, Thanks, Shubham. We have so many questions from Roy. Okay, so one of the questions is what are the source DBs in roadmap? I guess those are already answered. Moving on to the next one. I see you talk primarily about S3, and I guess HDFS will also work.
Yes. Again, like we are an open source project. As of now, right now we don't support, but I don't see any challenges because we are using Iceberg Java as a writer. So HDFS is already supported there. So we can add the like required settings if a feature request is raised on the Slack or even on the GitHub. It's not gonna be like more than a 1 week of effort. Yeah.
All right. Moving on to the next question, we have Pankaj, and his question is what kind of data was used for benchmarking? How many entries were used in each row? Did we try TPC sort of benchmarking on Iceberg's side?
So there are two side of things here. One is the benchmark that we did as a part of ingestion. So ingestion was done on the NYC taxi dataset, which is again one of the famous datasets. We ingested almost 4 billion rows, and there is a really detailed blog present where on how we achieved this benchmark as a part of the benchmarking. So we use the NYC taxi dataset, but particularly for the like query side of the things, right? We have not done any benchmarking, particularly just on the query, because TPCH and TPCDS are primarily used for queries. Uh, but again, like I think there should be tons of benchmarks around the query side of the things as well for the Iceberg, so you can check online.
All right. I hope, Pankaj, that answers your question. Moving on, Lokesh has a question. How critical are real time decision making capabilities, and what would be the business impact of data pipeline failures during peak periods? I think this is an interesting one.
Yes, this is an interesting one, and I have faced this many times in the past. So I have a 10 years of experience as a data engineer, and this is one of the most difficult times when your data pipeline breaks and middle of the night you get calls that okay, we are not able to see some level of metrics. I think particularly in real time decision making, I would say like in terms of Iceberg, you can with the OLake you can go as low as like a minute, and in terms of the use cases side, there are tons of use cases when it comes to getting the data near real time. I would say there is a real time where you need a sub-second kind of latency where you analyze the data while it's in the transit, and there are some level of capabilities which you have to have in terms of, let's say, near real time. So the use cases with near real time kind of a frequency could be some level of reconciliations, some level of basic business metrics like how many monthly active users, daily active users, what is the count of, let's say, revenue. All of these metrics are really important for the near real time kind of a decision making where you get the data freshness of around 5 minutes or more. And if a pipeline breaks, right, and this is where things get interesting. So a lot of your business metrics in terms of consumer facing metrics are the affected first. So a lot of consumers start raising the complaint that okay, we are not able to see our own analytics, like whatever they are tracking in your B2C or a B2B app. Apart from that, like you do get a lot of problems when it comes to if your pipeline is not idempotent. So if your pipeline breaks and you have to basically backfill the data, these are one of the most painful ones I have seen. If you have not created your pipeline so that whenever they started from the point where the things have failed, that's one of the bad designs. and particularly if you design it, you will have to do a lot of manual work to get your data and metrics back up, right? Because getting the data again up to the point is really difficult. Yeah.
All right, moving towards the next one. So Bunty has a question. How are we claiming the less cost factor here? Have we done any benchmarking with petabyte scale of data? Why Iceberg and why not Hoodie? At the end of the day, if we are processing more data, we have to spin up the source resources. What is that unique thing with OLake that stands out?
Okay. So couple of things. One is we don't need any of the heavy big data processing systems like Spark. That is one. We are written fully in Golang. So our memory footprint for the data pull side is actually 4 to 5 times less than a basic Java based connectors. So that's another. Apart from that, like the cost factor is there. Like already some benchmarks are there on our website. So if you go to olake.io and scroll down, you will see a lot of benchmarks. So particularly cost is lesser because we have considered the cost of running the instance. We have ran the benchmarks on a 128 GB machine, and for a full load, it ran for 24 hours for loading almost 4 billion records, which were in terms of the size, or the size was almost more than a terabyte. And we ran the benchmarks on that. So for that, the cost of running that 128 GB machine was around a couple of dollars. It's not more than like $10-20. But when we compare the same cost with the other tools like paid offerings like Fivetran or Isturi or Earbyte, they have the calculators present. So we have calculated the exact price basis on how much data volume we have sent or how many number of rows we have sent. And that's also mentioned on our website and also on the blog that I just talked about, where we mention on how the benchmarking was done, right? And just to answer your question on uh, why not petabytes of data, because benchmarks are usually done on a couple of terabytes. Petabytes, it just takes really huge amount of time, and 1 terabyte can be a good kind of a like a reflection of how it would behave on a petabyte scale. So that's there. Apart from that, why not Hoodie? What we believe in terms of the adoption of the lake houses, Iceberg has the highest adoption, and it's also growing really quickly, has a really strong community support. That's one of the reasons why we have not chosen Hoodie and the Iceberg. Hoodie is primarily like the support for Hoodie in terms of Snowflake or Databricks is not that well. So that is one of the reasons.
Uh, okay. Moving on to the next one from Saurav. How are toast data from Postgres handled in case of OLake?
I think I don't have the answer to the question, but I'm assuming Duke or someone from the team can answer the question because, like I have not seen the specifically the toast data type as of now. I have not tested it yet, but somebody from the team can answer on the chat.
All right, Saurav, you'll be getting the answer from some of our team members soon. Moving on, we have Ibrahim who has asked, do you have plan to add Delta table as destination?
As of now, the Delta table is not in the roadmap, but you can raise a feature request on the GitHub repo, or you can basically add a poll on the Slack as well. We can definitely think about it if we have a lot of interest from the community or a lot of people are upvoting that format. But as of now, it's not on the table.
All right. Moving on, another question from Lokesh. What are your current data validation and reconciliation capabilities?
So in terms of data validations and reconciliation capability, so as we mentioned, like we are going to add a lot of data freshness metrics, data kind of like data metrics around how many rows are synced and like what was the last checkpoints and all of the things. So data validation will be done after we introduce the monitoring and metrics features. But like that's like at least 1 to 2 months down the line, we are going to slowly introduce all of this. In terms of reconciliation, I think we have created a pipelines in a really idempotent way. So if your pipeline fails at any point, you should be able to reconcile or get your data like backup when you run the sync again. So in terms of reconciliations, the design itself is idempotent. So you just need to trigger the sync to get your data reconciled.
All right. We have another question from Shabaz. If a commit fails midway, how does Iceberg ensure durability and prevent partial writes?
So that's what really good about Iceberg is it is fully ACID compliant, right? If a commit fails midway, the metadata which is going to expose the failed files, right, the partially written files, is not going to be replaced in the catalog. So you'll not be able to see that half done or partially made commit, because Iceberg, the only reason why Iceberg has a catalog present, one of the primary responsibilities of a catalog is to basically lock and replace the metadata, so you see the next commit or next snapshot of the table, right? So I think Iceberg inherently has that support as a part of its offering.
All right. Another question is from Federico. He is asking, is it ready for sync schema evolution?
Yes, as a part of the presentation, as I mentioned, like we do have all the basic schema evaluation things done, where you add a table, where you add a column in a table. If you delete a column from the source, if you rename a column, all of that is going to be replicated in the Iceberg table. For the schema evaluation, when it comes to data type conflicts, as I mentioned, the DLQ column would be created and your data would be dumped. If your data type has a conflict, like if it was coming in the end previously and now it's coming as a string. So we do have that feature. Like that feature is going to be launched by next sprint in next 15 days or so.
All right. We have a question from Gaurav Singh. Can we use OLake for OLTP2 or is it just for OLAP?
I mean, like you have OLTP as your sources, and then you like all the OLTP like databases. Then you dump the data into Iceberg, which is primarily used for OLAP. So I would say like we don't have from OLTP to OLTP kind of a thing, or OLAP to, as of now we don't have any OLAP sources also. So it's from OLTP to OLAP, if that's what the question is about.
All right. We have another question. What do you want to say to people who want to move from legacy stack to Iceberg? Ankit's question.
I think it's a good question. Like we have been doing a lot of discoveries around these things. Couple of discoveries that came in where like there are two types of people here in the Iceberg domain. One type of people who already have a data warehouse set up like Snowflake or Redshift and BigQuery. For them, the migration is going to be a little tricky because they have already some ELT pipelines dumping the data into these warehouses. So they might have to do a little bit of rewrite of their ingestion or ELT pipelines so that they can eventually move to Iceberg. One of the good things about this is now Redshift and BigQuery, all of them support the querying from Iceberg as well. So they can move it really step by step. They can move the pipelines one by one and still don't have a really big issue on their dashboards because they can still query the same data in the Iceberg table rather than the native formats, right? So this is the first category of people. The second category of the people that we see who have their data into Hive and Spark kind of ecosystem, and the data is stored in HDFS or S3 as a part of the Parquet. With this kind of people, I think one of the easier migrations strategy could be that you regenerate the Iceberg metadata on top of your existing Hive tables, but that involves a lot of management and doing it really carefully because you need to be really careful when you switch from that Hive queries to this. Like Iceberg, newly created Iceberg metadata table queries, there could be some the synchronization or the data ingestion locks that might be necessary. And there is a really great blog from the Netflix side, which is there for this Hive to Iceberg migration, because Netflix is one of the companies that has done a petabytes of data migration from Hive to Iceberg. So you can also go ahead and see that blog. But I think that these are the two strategies. For the Hive table, you can just simply generate the metadata. You don't have to migrate the whole data again to Iceberg, and your tables will be compatible with Iceberg.
Yeah, thanks, Shubham. We have last two questions. One is from Swati. How OLake handles reordering, dedupe, and upserts without external orchestration?
So particularly, I would start with upserts and dedupes. Upserts and dedupes are handled as a part of equality deletes. So whenever you whenever your data is updated as either a part of CDC or let's say some level of incremental sim that you're running, we get that data and we create an equality delete file. What a equality delete file means is, let's say you have 1 million rows which are already stored in your Iceberg data lake, and then we have, let's say, 100 rows which are updated. In for those 100 rows, what will tell Iceberg is like you with this ID you delete the older data that's present, and you assume that this is the new format or the new version of the data that's there. So Iceberg, and this is what is called equality delete. We also have a really good blog around equality delete versus COW versus positional delete. So you can check out on how it works. But as a part of the when you're reading the data, Iceberg, all the query engines which support equality delete reading, they will come and they'll see that okay, maybe this 100 rows are now deleted from the old table, so I have to handle this data on the fly, and I'll only read the new versions of the data which is present in the equality delete. So that's how it works. Maybe I answered the question, or I have not, but you can read that blog where we explain how the equality delete works. So I think I answered half of the question.
Yeah, yeah. We'll be sharing the blog links in the chat. Please go and check it out. Yeah. Towards the last question, I think this is something which everyone has in mind, but nobody asks. If I run OLake on EC2 instance, can it pick up the AWS creds directly from the machine config instead of the AWS secret and access keys?
Yes, I think I have already showed it in the demo. So we have both. Like if your machine is configured with the IAM, so you don't need to put in the secret key and access key. It can directly pick it. Or if you want to pick it, if you want to add it explicitly, you can do that as well. So we support both the modes.
All right, we are done with the questions. Thank you, Shubham. Thank you so much for the presentation. And we have a really exciting announcement towards the end. Over to you, Harsha.
Hey guys. Hi guys. So, an amazing session, amazing, wonderful engagement as well. We had so many interesting questions and insightful answers to those. So, kudos to the team, kudos to the contributors, and thank you so much, people, for joining in. And we have an exciting news for the people who is staying in Bangalore right now. So, on this upcoming Saturday, which is 5th of July, like the next Saturday, we are having an Iceberg Bangalore community meetup. I think this is the first time we're having a community meetup for Iceberg in India, Bangalore. So, this is an exclusive invite to the people here who has joined the webinar. I will be adding more descriptions and details over the weekend, and stay tuned. You can join in, you can register already, and we'll see you. The OLake team will all be there. Plus, we will have some great speakers as well. So, just wanted to tell you, yes, I think we are done. Anything that you would want to add, Shubham?
I think most of the people who have joined, I would like to ask them to join the community on Slack, and you can ask tons of the questions which you were able to either ask in this meetup, or you missed out on asking in this meetup, or maybe I can answer in more detailed way there as well. And do check out the product, do check out the UI. It's really simple. You just have to go to the Docker repo and just simply do Docker compose up. You should be able to spin up a OLake UI and the orchestration really in just like 5 to 10 minutes. Definitely, if you have a good internet.
And yes, please, guys, like your feedback is invaluable to us. Please do join the community and, put your feedback after looking into our UI and using us. It will be a lot of, it will be really helpful to all of us. And we are here to, send improvements as well all through the way. Yes, thank you. Thank you so much. Thank you so much, people. Thank you so much, Shubham. And thank you so much, Merlin. The session was really engaging and I enjoyed and learned a lot from you guys.